I used to work at Cisco. This was this year, by the way, and I watched the firewall team work their absolute butts off during this. Now, so Cisco experienced a significant security incident, and it demonstrated the evolving threat landscape. The attackers leveraged compromised credentials to infiltrate less secure development environments. From this initial entry point, the threat actors exploited flat network structures to pivot towards more sensitive production environments. This incident highlights that attackers rarely strike the most fortified targets directly, they instead look for paths of least resistance. The ability of attackers to move laterally from a development zone into a critical production infrastructure demonstrated the risk of insufficient internal segmentation. Without granular internal boundaries, defense in depth, the compromise of a single development asset quickly escalated into a wider network security issue. Had strict micro-segmentation been enforced, the initial breach of the development node would have been effectively isolated. Now, impact would have been contained to a specific non-critical segment, preventing unauthorized lateral movement. This video, we're going to cover the essential mitigation techniques of segmentation and isolation designed to restrict lateral movement to protect critical assets. Network segmentation is the practice of splitting a physical network into multiple, distinct subnetworks. The logical division is primarily achieved through VLANs, virtual local area networks. This is like cutting your switch in half. VLANs operate at level 2, the open system interconnected model. Now, VLANs group devices together logically, regardless of their physical location, preventing broadcasting traffic from crossing between groups to enable communication between different VLANs. Routing must occur at layer 3. Subnetting is the process of dividing an IP network into smaller logical network segments. So, switches are level 2, routers are level 3. That's about as deep as you got to get for Security Plus, but you can do whole certifications on this stuff. While subnetting optimizes network performance, it also serves as a foundational security boundary. Security administrators implement access control lists on routers and firewalls to control traffic between these subnets. Access control lists define strict rules regardless of which IP address the ports are on. A classic application of network segmentation is a DMZ, a demilitarized zone. A DMZ is a physical or logical subnetwork that contains and exposes external facing services to the untrusted internet. Web servers, mail servers, DNS servers reside within the DMZ. The DMZ acts as a buffer zone, preventing external users from gaining direct access to the internal corporate network. We have our DMZ over here and our corporate network over here. For most critical assets, organizations utilize the ultimate form of segmentation, the air gap. An air gap is a security measure that ensures a secure computer network is physically isolated from the unsecure networks, such as public internet or unsecured local area networks. Air gap systems are used in industrial control systems, military networks, and life-critical medical environments. Data transfer to an air-gapped system requires physical media, such as a thoroughly scanned USB drive, which introduces a high level of operation friction, but maximum security. Traditional network segmentation relies on physical hardware such as firewalls, routers, which often manage the traffic at the perimeter. However, modern data centers and cloud environments contain massive amounts of east-west traffic. East-west traffic refers to the data transfer that occurs internally between servers, virtual machines, and containers. Traditional perimeter firewalls are blind to this internal traffic, creating a significant security gap. To address this challenge, organizations implement microsegmentation. Microsegmentation is a security technique that enables fine-grained security policies to be assigned to individual applications, workloads, and virtual machines. Instead of securing an entire subnet, microsegmentation secures each individual workload. This granular control prevents lateral movement even if an attacker compromises a service within the same subnet. Now, microsegmentation is highly dependent on software-defined networking, or SDN. SDN decouples the network control plane from the physical forwarding plane. The control plane determines where traffic is sent, while the data plane forwards the traffic. I got asked this in an interview, by the way. By centralizing network, SDN allows administrators to programmatically configure and manage network services. Security policies can be dynamically updated and applied to workloads automatically, regardless of where workloads resides in the physical infrastructure. While segmentation focuses on network architecture, isolation focuses on restricting the environment of specific host or application. Host isolation is a critical incident response technique. When a security analyst detects compromised endpoints, the analyst must immediately isolate the host from the rest of the network. This action prevents the malware from spreading to other systems or communicating with external commands and control servers. Modern endpoint detection and response agents allow remote isolation while maintaining secure channels for forensic analysis. Another powerful technique is sandboxing. Sandboxing is a tightly controlled way of doing things. A sandbox is a controlled, isolated environment where untrusted programs or code can be executed safely. Security analysts use sandboxes to analyze suspicious files, emails, or attachments, or software updates. If a file contains malware, the malicious behavior is observed and documented without risking the integrity of production networks. Isolation is also achieved through virtualization and containerization. Virtual machines isolate operating systems from another one on the same physical hardware as its hypervisor. Hypervisors are like the tool that's used to split up these servers. Containers isolate individual applications from their dependencies, sharing host operating system kernels but running isolated workloads. Both technologies ensure vulnerabilities in one application or operating systems do not automatically compromise the entire physical host. That is a ton of information, but the long story short, whether it's VLANs or software defined networking or subnets, it is best to keep stuff isolated, right? So we try and separate what we need to separate, and we use whatever tool we can to do that because thing works at different layers, right? And if we have a big network, we can physically separate them, right? We can disconnect this from the internet. This doesn't have to be connected to the internet. We're doing this internal. And then we can say this is going to be exposed to the internet, but we're going to take that little subgroup of that. We're going to say that's our DMZ. We're going to put that right here. And this doesn't have access to the rest of our stuff, right? Maybe just like a management thing, but it doesn't get access. You can't go from your Active Directory server here and talk to your Active Directory server somewhere else. Now, split it up. That's what I'm saying. Got a whole bunch of technologies and there's lots of vocab words here, so I highly encourage you to go and read the study guide that's available in the Udemy. Look at the different things because networks are deep and complicated. I plan to make a video where I go through all of what real IT infrastructure looks like, so stay tuned for that.